Chapter 2, Water Tanks and Hose Capacity. Got a lot of objectives for this chapter. Understand the various types of tanks used in the fire service. Determine the area of a square, the area of a rectangle, and the area of a circle when the dimensions are given. Solve problem to determine the volume of a rectangular container. Solve a problem to determine the volume of a cylindrical container. Determine the gallon capacity of either a rectangle or a cylinder container. Solve a problem to determine the weight capacity of either a rectangular or a cylindrical container. Determine either the weight of the water or the amount of water in a hose line of various size. Water tanks are used in the field of fire protection on fire apparatus, in industrial establishments, and within the water supply system of many cities. The construction standard for water tanks on fire apparatus are contained in NFPA Standard 1901. Standard 1901 recommends that water tanks on fire apparatus have a minimum capacity of 500 gallons, except aerial ladders or elevated platforms. Initial attack pumpers carry a minimum of 200 gallons, and mobile water supply vehicles carry a minimum of 1,000 gallons. Now, all these numbers sound like an excellent test question. The tanks used on pumpers are generally rectangular in shape. Most are made of plastic material. Rectangular tanks are seldom used for water storage in industrial establishments or as a portion of the water supply system of cities. The gravity or suction type water tanks are most often used for these systems. The gravity tanks may be cylindrical with pitched roofs or elliptical or hemispherical. Steel gravity tanks are available in standard sizes ranging from 30,000 gallons to 500,000 gallons in capacity. Alright, a square foot is a flat surface with four sides measuring 1 foot each and having four 90-degree angles. A square inch is a flat surface with four sides measuring 1 inch each and having four 90-degree angles. There are a total of 144 square inches in 1 square foot. Okay, and the way we get this simply is multiplying our height and width. Now notice I'm putting 12 down. Why is that? Because that's a measurement of a foot and we have to reduce it or change it over 2 inches. So there are 12 inches in a foot. And then 12 times 12 equals 144 square inches. Alright, let's talk about cubic feet. A cube has equal lengths of width and height. So we're going from a two-dimensional object to a three-dimensional object now. A cubic foot is 1 foot long, 1 foot wide, and 1 foot high. As we learned in Chapter 1, there are 1,728 cubic inches in 1 cubic foot. Again, let's look how they got that answer. And basically our formula is length times width times height. And again, we're going to change this over to inches instead of feet. So that's 12 times 12 times 12, our length, width, and height. And that is going to give us 1,728 and 28 cubic inches. And that is CUIN, cubic inches. So let's look at the area of a square. A square is a flat surface with 4 equal sides and 4 right 90-degree angles. The area of a square can be determined by using the following formula. S to the second power. So let's say if we had a square that was 12 inches by 12 inches, or a foot by a foot, we would simply take the side and times it by itself. So 12 times 12 is what, gang? Okay, here's another example. And again, the question is, what measurement you want at the end. And last time we did square inches, so this time they're showing you square feet. So if we have a square with a side of 3 feet, we know all sides are going to be equal, so 3 times 3, or 3 to the second power, is 9 square feet. Again, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, 3 times 3 equals 9. A rectangle is an oblong flat surface with parallel sides and 4 90-degree angles. The area of a rectangle can be found by using the following formula. Area equals length times width. So if we had a length that was 3 feet and a width that was 2 feet, 3 times 2 would be what? 6. All right, here's another example. 6 times 8 gives you an area basically of 48 square feet. And then if you want to change that to square inches, it could be 48 times 12, and that will give you the number of square inches. A circle is a flat figure bound by a curved line. All points on the curved line begin equal distance from the center. The area of a circle, as used in calculations in the fire service, is usually expressed in square feet or square inches. Don't let that trip you up. Make sure you figure out what they're asking for on the questions for the math problems. Either one of the following formulas can be used to determine the area of a circle. I recommend you just pick one that you can remember and go with it. Probably the easiest formula to use is 0.7854 times the diameter square, where d equals the diameter. Or you can use the formula area equals pi 3.14 times the radius square. Remember, d is the distance all the way across, and the radius is from the center point to the end. Okay, and this is actually on page 32, not page 71. Figure 2-8, the diameter of a circle is 3 inches, so they've already given that one for us as opposed to the radius. So to figure out the area of this circle, you plug it into our formula. Area equals 0.7854, which is our constant, meaning it's always going to be that, times 3 squared. Remember, you do any exponents first or things in parentheses. So 3 times 3 is 9, and then 9 times 0.7854 equals 7.07 square inches. And that goes back to our diameter being square inches that they gave us originally. Alright, so here's an example of one of your questions. How many square inches are in a 1/2 inch tip? So we're looking for the area, right? So area equals 0.7854, which is our constant in our formula, meaning it'll always be that, times the diameter square. Remember, the diameter is the total length across of our opening. So 0.7854 times 0.5 square, because we take a 1/2 inch tip and we turn that into a decimal. A little old school math here for you, because 2 can't go into 1, right? But 2 can go into 10. So to bring up the 0, we put our decimal point there. So 2 into 10 goes 5 times, and 5 times 2 is 10. So that gives us 0, so everything equals out. So 0.5 is our decimal. Now remember, you do exponents first, so don't do 0.7854 times 0.5 and then square it. That'll give you the wrong answer. It's 0.5 times 0.5, and then you multiply that times 0.7854, which gives you basically 0.2 square inches. Okay, so here's some general knowledge stuff. We understand how they got it, but if you want to apply these numbers to memory, that'll work too. For a 1/2 inch tip, the area is 0.2 square inches. For a 1 inch tip, the area is 0.8 square inches. So as you can see, when the size of the tip is doubled, the area is increased 4 times. Okay, the volume of a water tank is normally expressed in cubic feet. The volume of a hose is expressed in cubic inches. The volume of both rectangular and cylindrical containers is equal to the area at the base of the container times the height of the container. There are 2 different formulas that we will be using to figure the volume. The formula for determining the volume of a rectangle container is volume equals length times width times height. Okay, again, volume equals length times width times height. Okay, notice width, length, and height. Multiply all 3 together, and that gives us your area, or excuse me, volume. The next formula to find volume of a cylindrical container is going back to 0.7854 times the diameter square times height. So let's look at a problem. What is the volume of a rectangular container that measures 11 feet by 7 feet by 8 feet high? Plugging in our numbers, volume equals L times W times height. Our L is 11. Our width, our wide, is 7, and our height is 8. So 11 times 7 times 8 gives you 616 cubic feet. And the reason it's in cubic feet is because that's what our measurements were. Alright, looking at our cylindrical object. It has a diameter of 12 feet and it is 18 feet high. So 7.854 times 12 squared times 18. Again, we need to multiply 12 times 12 first. That way we get the right answer. So 12 times 12 is 144. And we've got to multiply that times 18 and times 0.7854. We multiply that all together, and that gives us a answer of 2,035.76 cubic feet. Gallon capacity of a container. How many gallons are in a cubic foot? And that answer is 7.48. And all you simply do is multiply the cubic feet by 7.48. So let's take this a step further. And basically, again, we're measuring or multiplying the capacity, which is 7.48 times the volume. And remember, we got to get the volume by using the formula length times width times height. So we basically have two problems to put together to get our answer. So let's start out with how many gallons of water can a rectangular container hold if it is 18 feet high and its space measures 10 feet by 10 feet. Alright, so we got to figure out the volume first. Volume equals length times width times height. So now let's plug in our variables. We have 18, we have 10, and we have 10. So 10 times 10 times 18 equals a volume of 1800. And what's this going to be in? Cubic feet, because we multiplied and they gave us feet here. So our volume is 1800 cubic feet. Now, let's go back to the other part of the equation. Gallon capacity is 7.48 times our volume, which is 1800, and that equals the, and I'm just going to abbreviate this, GPC. So when we multiply 7.48 times 1800, we get 13,464 gallons. And here's a little cleaner version here. Length times width times height, 10 times 10 times 10 times 18, 1800 cubic feet. Then we multiply that by 7.48, which gave us that number of 13,464. Alright, have you ever wondered how many gallons of water are in a swimming pool? A swimming pool may be needed as a static water supply to fight fire. A rectangular pool is 40 feet long, 15 feet wide, and has an average depth of 5 feet. So I know that most pools range from like 3 feet to 8 feet, on the deep end, so they kind of split the middle and got the difference of 5 feet. So, again, what is our volume going to be? Because we got to figure out volume equals length times width times height. So we have 15 feet wide, 40 feet long, and we're going to say our height, being the average depth, is 5. So 40 times 15 times 5 gives us a volume of what? And that's going to be 3,000 cubic feet. And then we again multiply that by our constant, because 7.48 to get our gallon capacity, because our gallon capacity is 7.48 times the volume, and our volume is what? 3,000 cubic feet. When we multiply them together, we get 22,440 gallons. So now let's look at a cylindrical container that has a diameter of 12 feet and a height of 25 feet. Volume is equal to 2,827.44. So how did they get that number? The solution is 21,149.25 gallons. So how did they determine this? So let's look at our formulas here. First, gallon capacity formula is GC is 0.7854 times the diameter squared times height. So, volume is 0.7854. The diameter squared is 12, so 12 times 12, 144. And then, of course, times that by 25, which gives us an answer of 2,827.44 cubic feet. So then we take that number and we multiply that by what? 7.48. So 7.48 times 2827.44 gives us an amount of 21,149.25 gallons. So how much does that all weigh? Here's the formula that you're going to use. We can convert volumes or gallons to pounds with simple math. Multiply the volume by 62.5, the weight of 1 cubic foot of water. So, question, what is the weight of water in a tank that is 12 feet wide by 15 feet long and 22 feet high? So, our problem is 62.5 times the volume is equal to weight. Well, we don't have the volume, so what formula do we use to figure the volume of this container? And that's going to be the length times width times height. So, plug in your numbers. 12 times what? 15 times 22. So 12 times 15 times 22 equals what? (3,960 cubic feet. So the volume equals 3,960 cubic feet. Then all we do now is multiply that by 62.5, which gives us a grand total of 247,500 pounds. A lot of weight there. All right, a cylinder container is going to be the same way, okay? Diameter of 15 feet and a height of 30 feet. So volume, we have to get that by doing 0.7854 times the diameter square times height. So 15 times 15, 225, times our height of 30, times 0.7854 gives us a volume of 5,301.45. And then, of course, we multiply that by our constant, 62.5, to give us the grand total weight of 340.63 pounds. Okay, one objective for this chapter is to offer insight into the capacity of varying size of hose lines. Hoses used in the fire service can range anywhere from 3/4 of an inch to 6 inches in diameter. The weight of the hose is important to us because of problems involved in moving loaded lines, especially to the upper stories of buildings. Simply put, a section of fire hose is just as a long cylindrical container. About the only difference between the containers and the fire hose is the unit of measurement. The volume of a cylindrical container is expressed in cubic feet. However, the volume of the hose is usually expressed in cubic inches. That way it gives you whole numbers and not decimals or fractions. So we're still going to use the same formula, but instead, for our value at the end, it's going to be square inches. So, what is the volume of 50 feet section of 2.5 inch hose? We know that V equals 0.7854 times the diameter square times H. To determine the height, or in this case length, because we're thinking about a hose, you have to convert feet to inches. Don't forget that. So we know that you have 12 inches in a foot. This is a 50-foot section of hose. So 12 times 5 gives you what? 600 inches. So now we have everything in place to figure out our answer. Volume equals 0.7854 times 2.5 times 2.5 times 600. And that gives you an answer of 2,945 cubic inches. So now let's start looking at the gallon capacity of that. The gallon capacity of a hose line. The gallon capacity of a hose line is found by finding the volume in cubic inches and dividing it by 231, the number of cubic inches in a gallon. So the formula is gallon capacity equals volume divided by 231. And notice they want the volume in cubic inches, not cubic feet. So let's start this off. How many gallons does 100 feet of an 1.5-inch hose hold? Volume equals 0.7854 times the diameter square times the height, or in this case, again, the length. And the length has to be in inches. So 100 times 12 gives you 1,200. Our diameter, 1.5 times 1.5 gives you 2.25. And then our constant, 0.7854. We multiply all those together, and our volume is 2,120.58. So now we want to get the gallons. To get the gallons, you divide that by 231. So the solution is 9.18 gallons. Alright, so firefighters often ask how many gallons are in a 100-foot section of 5-inch hose. What is the answer? And the answer is 102 gallons. How did they determine this? Other question, how much does the hose weigh? Answer, 851 pounds. So, let's figure out how they came up with these answers. Okay, to figure this out, there are three formulas we are going to have to use. Gallon capacity equals volume divided by 231. Volume equals our constant, 0.7854, times diameter square times the height, or in this case, again, length. And then our weight formula is gallons times the constant of 8.35, which gives us our weight in pounds. So let's start out with our volume formula first. So that is going to be 7.854 times the diameter square, which was 5, because it was 5-inch hose, times the height, which was 100 feet of hose, and we want to change that to inches, so that's 1,200. So 1,200 times 5 times 0.7854 gives us a volume of 23,562. So now we get our gallon capacity by taking 23,562 and dividing that by 231, and our gallon capacity is going to be 102. So 102 times 8.35 gives you your weight. And what is our weight? 102 times 8.35 equals 851.7 pounds. Alright guys, so you had a lot in this chapter to digest. Look through the examples in the book. practice doing the math problems. If you have any questions, either hit me up during the virtual office hours or shoot me an email, and we'll get it all figured out together. Until then, you guys have a wonderful day.